or components and their various meanings. The first one we are going to discuss is switch. The first one we are going to discuss is switch, and these are the two symbols. One is open switch, and the second one is closed switch. First of all, we need to understand what a switch is all about. A switch is an electronic or electrical component that makes contact. By pressing on it, it makes contact. You press on it again, it opens. When it makes contact, current flows around the circuit. When you press it again and it opens up, just like what we have here, all right, just like what we have here, no current flows under this condition because it's open. That's what a switch does in an electric circuit. The second component we are going to consider here is lamp. A lamp is also an electrical component or electronic component that heats up when there is a source of energy. When there is a source of energy, it heats up the filaments, giving out heat. That's energy, right? Giving out heat as light. That's what lamp does. All right, and we have the component or the symbol here. Look at the symbol for lamp. It could be represented with another symbol, but very similar to this. All right? Okay, then we talk about, let's discuss fixed resistor. The next component is a fixed resistor. Then by its name, going by its name, we ask ourselves, why is it called fixed resistor? It is called a fixed resistor because the limits, the value of that resistor or the resistance of that resistor is fixed. It doesn't change. It's a resistor that restricts or limits the flow of electric current, okay? The flow of electric current around the circuit. It is fixed because it doesn't change. That's why it is called a fixed resistor. Now let's look at the symbol of a fixed resistor. A fixed resistor, look at the symbol. Look at it. Very plain and looks smooth. So it's a fixed resistor. The next component we are going to consider here is variable resistor. Variable means it changes. The value of the resistance here changes, especially when there is a slider moving on this resistor. When there is a slider sliding on the resistor, the value of the resistance changes. That is why it is called a variable resistor. Okay? Yeah. Then let's look at the symbol. The symbol of a variable resistor. Can you see? This is a variable resistor. Right. Variable resistor. It changes as the slider moves on the resistor. All right, so we look at the next thing we're going to do here is we try to understand, to give us some support. We need your support. Kindly support this learning by subscribing, liking, sharing, and giving the video some thumbs up. Subscribe to this channel, all right? Give us some thumbs up. Share to your friends and their numerous networks. Then click the bell button so that each time a video like this is uploaded, you will be among the first individuals to be notified. You can do more than this. Support us. That's all. That's all we are asking for. Thank you. All right, let's proceed. The next is our conclusion. We are going to look at what we have next, which is the continuation of electrical symbols or components and their various meanings. The next component we are going to consider here is what we call transistor. Before I show you the symbol and then illustrate what it means, I want you to understand that this component functions on the principle of thermal energy. All right? Thermal, that is heat energy. Thermal energy is simply known as heat energy. So let's see what happens. The resistance of a thermistor depends on its temperature. This is thermistor, right? from the word thermistor, thermal. It has to do with thermal energy, right? And look at the symbol here. This is the symbol of a thermistor, right? So let's see what happens. The resistance of a thermistor depends on its temperature, as I said earlier, right? At low temperatures, the thermistor has a high resistance. Remember, I said at low temperature, the thermistor has a high resistance. Conversely, as the temperature increases, interesting, the resistance decreases. Look at it. When the temperature reverses and starts increasing, the resistance of a thermistor starts decreasing. That's one thing so surprising, a mystery we are supposed to unravel concerning a thermistor. All right? Now, the good thing is that thermistor is used as in thermostats or heat-activated fire alarms. Thermostats are found in electric irons, and then fire alarms where there is heat, anything that applies thermal energy. Thermostat can be used as a component to regulate the flow of thermal energy in that arrangement. Then the next one is light dependent resistor, LDR. I repeat, LDR. Okay, this component is powerful. And look at the symbol here. Look at the symbol, light dependent resistor. This is the symbol. All right. So what does it do? Very fantastic. The resistance of a light dependent resistor depends on light intensity. Light intensity, what does it mean? The amount of light per unit area. Okay? That is what it means. So when the light intensity is low, what happens? The LDR has a higher resistance. I repeat, when the light intensity is low, the LDR has a high resistance. As the light intensity increases, with the increase in the light intensity, what happens to the resistance? It decreases. That's how wonderful LDR can be. So, but the good thing is that LDR has come to stay. It has found wide applications in our various homes, on the streets, and so on and so forth. So at home, it's found in cameras for security purposes, also, or automatic lights that come on when the day gets dark. Okay, you can find it as well on streets and the remaining aspects of our structures around. Then the next component we need to consider here is the semiconductor diode. When you hear the word diode, one thing that should come to your mind is that it converts alternating currents to direct currents. If you can just remember, diode. My uncle, my teacher says that a diode, a semiconductor diode, converts alternating currents to what? Direct currents. That's all. That's what it does. Because it allows current to flow in one direction. Because of this quality, that's why it is used as a rectifier to convert alternating current into what's a direct current. That's all. All right. There are some components that have not been covered, which I'm going to quickly explain because they are common to us. These are components we know already. So let's begin with voltmeter. A voltmeter measures the amount of potential difference across 2 points in a circuit. If we have point A and then point B, then you want to know the amount of potential difference. Walk down from point A to point B. You connect what we call a voltmeter. And you are going to do this connection in parallel with the lamp. With what? In parallel with the lamp. The voltmeter has to be connected in parallel with the lamp in the circuit for you to be able to measure the potential difference across 2 points. As I said earlier, A and B, or any letter of your choice. All right, so let's quickly look at another symbol here that is also common to us, ammeter. The symbol for an instrument known as ammeter is this, okay? So what does an ammeter do? An ammeter is a device that measures small amount of currents that flows around a circuit. That's clear, all right? How can it be used in a circuit? You connect this ammeter in series, not in parallel. You connect it in line, end to end, with the bulb or with the lamp. That is in series, to know the amount of current flowing, no matter how small the current is. There is another symbol or another component that should have been introduced here, but maybe as time goes on, we're going to introduce it, and that is called galvanometer. Galvanometer is also another component that measures currents. But one good thing about a galvanometer is that it does not only measure currents, it detects it. No matter how small the current is, it notices that, hey, current is passing by. It detects it. After detecting it, it measures it, tells you the quantity, the amount of current passing at the moment. Unlike ammeter, an ammeter doesn't do that. An ammeter just measures but doesn't detect current. And that should be anchored on how sensitive a galvanometer is. So a galvanometer is more sensitive than an ammeter. We're going to go into that as time goes on, all right? For the sake of time, because I don't want this video to be longer than expected, right? Okay. This one is going to be given to you as an assignment because I know, since I have mentioned light dependent resistor, this should be light emitted diode, all right? Light emitted diode. You can see the symbol showing that it emits light. Look at these symbols. These two arrows pointing downward shows that these absorbs light. This one shows that this component emits light. So as an assignment, as a homework, go and use your smartphone, use your Google search, find out what light emitted diode is all about and its functions. Quickly, the next one is fuse. A fuse is an electrical or electronic component that cuts out in the event of excess current. When there is excess current flowing in the circuit, current that may destroy our appliances, the fuse cuts out, breaks out. And then as it breaks out, current stops flowing because there is no connection again. That's what the fuse does. But if the current coming is moderate, according to the value assigned to it, moderate current coming, the fuse will remain intact, it will not blow out. It will remain intact and allow that moderate current to pass through every part of the circuit into our home appliances and the rest. That is why fuses are found in every electrical structure or electronic structure because it acts as a protector. It's a device that protects. If there's something if current coming in is going to damage appliances around, the fuse comes into play by making a disconnection, right? It makes a disconnection and stops current from flowing. That's what it does. All right. And the next is this symbol here. Very, very important because they represent energy. All these things we are talking about, if we don't find a way to represent energy in our circuits, somebody may not understand where the circuit is getting its supply. So this, when you have two strokes, one long and the other one is short. I repeat, two strokes, one long and the other one short, is called a cell. The combination of cells, 2 cells, make up a battery. That's what you're seeing. The next one we are seeing here, okay? 2 cells make up what? A battery. So that's this. Combination of 2 cells make up a battery. We can still put another one. This should have been 3 long strokes and 3 short strokes, okay? But they just combined to, but there's no problem. It's okay, it's allowed. They're just trying to show that combination of 2 cells make up a battery. All right? So that is what we have to understand about electrical symbols or components and the various meanings. Let's see what we have next. Don't forget that this is an educative video or channel that will always keep us informed in terms of physics concepts. So please support us. Kindly support this learning by subscribing, liking, sharing, and giving the video some thumbs up. So remember to hit the bell button. Bell button, hit it hard. Okay, give us some thumbs up. When you hit the bell button hard, okay, anytime we upload videos like this, you'll be among the first set of individuals to be notified. Give us some thumbs up. Come on, you can do that. Share to your numerous friends and networks, all right? Like us and then subscribe. Do us that favor, subscribe, right? Subscribe more and more, because this is what you want. Thank you, and see you in our next class. Okay, and then we will continue like that. We have many more videos to shoot. Let's see how this one goes.